Hello, I'm Rahul from the Fun Robotics Network, and here with me is Team 9974 THOR. They are the most compact and lightweight robots I've ever seen in FTC, featuring custom Mecanum wheels, bare motor Mecanum drive, a turreted active intake, and an insanely lightweight deposit. Catch more on Behind the Bot. Hello Team 9974 THOR, thank you guys so much for being here. Now, obviously you guys have such a compact, it's like 11 by 11 or 12 by 12, and a super lightweight robot. Walk me into why you guys chose for this type of robot for Into the Deep.
So there is two main reasons. The first one being maneuverability. When you've got other robots trying to access the sub, it kind of lets us squeeze in better. And the smaller robot we have means that we can get more extension due to the new extension rules this year.
All right, thank you. I think that makes sense. Now, let's just jump straight into your drivetrain. Obviously, there's so much to talk about here. Your Mecanum wheels, your bare motor. Just walk me into the entirety of it, and then I'll ask questions.
Yeah, so our entire robot actually uses bare motors, and we did that for packaging reasons and to save a bunch of weight. Additionally, it is allowing us to gear everything to like an optimal RPM. And then our wheels are RevMech cages with custom molded urethane rubber rollers. Those are 30A durometer, so even though we're 18 pounds, it still gives us a lot of traction to not get pushed around.
Thank you so much. Now, just starting with your Mecanum wheels. Now, I see do you have any tips on teams who'd like to devise custom molds of their own? How have you seen that impact your like torque and stuff like that compared to other things like grip force mechanisms or other Mecanum wheels on the market?
Yeah, so like these we found they almost have twice as much traction as a grip force, and we tested that with like a static traction test. But the thing is, they are going to wear down a lot quicker on a heavier robot. Another thing is, we did try some silicone, but the silicone doesn't really adhere to the rollers well. So we did switch to a urethane rubber, but that added like a lot of challenges. So like when you're molding it, you have to use a lot of mold release, and then it has to be inside a vacuum chamber, or else you're going to get a lot of air pockets and bubbling.
All right, nice. Now let me just move on to your bare motor drive. I think you have a two-stage reduction here from the bare motor. Walk me into the belts and how that whole system works, and have you experienced any issues such as skipping or maintenance with these belts?
Yeah, so we use a two-stage reduction. It's GT2 on the first stage and then HTD3 on the second stage. We used Gates power belt calculations to find the right width and pitch. So that's actually why we use two different kinds of belts. And we first made just the chassis to optimize our center to center distance. And then once we optimized that, we built the chassis and haven't had any issues since.
Nice. I think that's really impressive how easy you guys are able to drive around the field. Now, just to get this question off the bat, how heavy are you guys currently with 8 bare motor mechanism, pocketed carbon fiber, and such a lightweight deposit?
We're right at 18 pounds, but we still have a lot of aluminum that could be swapped out for carbon.
No, that's really crazy. Now, let's just go into your extendo intake and your intake. Now, starting with your horizontal slides. You guys have a really thin stack of Misumi slides. I know a lot of teams have wider extensions. Why did you guys choose to have such a thin extension rather than having this placed on the outer plates of the robot?
So it's a very similar thing. Like maneuverability, when there's another robot in the sub, it can kind of let us just reach around them. And also when we're under the chamber, it's the same thing. It's much smaller. It allows us a lot more clearance when we're going to grab stuff.
Nice. Now, let's just jump into your intake. I see you have a turret, pitch, melon-bodic servos for the active. Just break me into everything into it and how that works and stuff like that.
So it's very similar to I believe Robotroopers. So it's like an intake claw hybrid. So we still have our rotation aspect and everything. But we decided to run the melon bots so we could get like a super fast intake. And then we're running a color sensor for detection and auto transfer. And before this competition, we actually added this little ramp here. So what that does is when we intake a sample, it orients it so that we can transfer consistently when we're running high basket.
Nice. And how have the melon-bodic super servos been for you? I know you have 2 of them. It seems 1-to-1 driven with some brown belt pulleys. Explain to me how that system works and how it's been for you.
It's been really good. We did break one on the first day of the competition, but we've been using them the whole season. So, I mean, they've been fairly durable. We have hit stuff you can tell by the scratches on there. So I think they hold up very well.
Nice. Now, on the side of the turret, can you show me how that pitch works? Is that a pocketed gear IC? And just how you use that until you have an autonomous?
Yeah, so when we're doing specimen scoring, we do a very similar strategy like what T.H.O.R does, so we can grab pitch out the side and drop while grabbing off the wall. And then we did pocket the gear. I more did that for fun just because it looked cool. But it did save us on the deposit because we put a zip tie here as our end stop so that the servo didn't wrap.
Nice, that's really cool. And now I see that intake is super cool. Let's just move on to your outtake. I see you have pocketed slides, a rail-based outtake, and a really thin carbon fiber claw. Just explain to me how all that works, and do you have some numbers on how heavy your entire deposit is?
I don't have any exact numbers, but it is, I mean, it's pretty much just the 3 servos, and then the MGN rail is super light. But we are running pocketed slides, which we found save 40 grams per slide, and it really adds up and helps us lower our center of gravity when the lift is up. Additionally, we wanted to be able to score specimen out the front, as that's a key part of our strategy, and we use a linkage so we can actually lock out the deposit, so none of that load is coming back into our servo.
Nice. Now, just on your outtake now, I see, why did you guys choose to have this carbon fiber-based claw rather than, the standard 3D print setup you see a lot of teams doing this year?
So we wanted like a really small, lightweight claw, and to do the ram specimen, we don't want like the claw to break or anything, and we actually let the specimen kind of dangle. So all we have to do is just drive into the bar, and it's been very consistent. We did originally do metal, but we found some issues with bending, so then we kind of went back to the drawing board, and we found that carbon was enough to prevent that from happening.
Nice. Now, I see your guys' robot is so amazing. Obviously, there must be a lot of sensors. Why don't you walk me through like some sensors you use? How do you use that color sensor you talked about in Talyup and Auto?
Yeah, so initially when we're grabbing, we have a color sensor here as well as an indicator light that can show drivers what they're picking up. It's pretty bright so we can always see. Everything from grabbing and scoring is all automated with double checking with the color sensor and making sure something's in there with a distance sensor that's combined. We also have encoders, a rev through bore encoder on the extension, and then we're using one of the encoder motors for one of the 3 lift motors, running PID loops on both the extension and the lift to ensure that we're going to the right place all the time. And then underneath, we're go build this pinpoint odometry computer with 2 dead wheels, and using that in our fast chassis, we're able to quickly score up to 6 specimens in auto.
Nice. Okay. Thank you so much, 9974 Thor. You guys have an amazing robot, so compact, so light. It's been truly amazing seeing you guys move speed around in the field. This is Rahul reporting from Fun Robotics Network. Catch you next time on Behind the Bot.